In this video, I'm going to find a transfer function for the given following electrical circuit. Now, the circuit is in time domain. How do I know it's in time domain? It is I0 of t, I input of t, and 2 Henry is 0.5 farad. If it is in j omega, or it's in frequency domain, j omega is nothing but frequency. That frequency domain is also called, it is similar to S domain, so I'm going to say the frequency domain and S domain are same. There is a little bit difference. Don't need to worry for this class at this point. Okay, so for this class, we're going to take j omega, which is frequency domain, is same as S domain. Okay, this S domain is nothing but Laplace transformation. Okay, that Laplace transforms we're going to learn next few chapters. At this point, just take frequency domain is same as the frequency domain is same as the Laplace domain or S domain. Now, I'm going to convert the given circuit into a frequency domain. So to convert this frequency domain, I'm going to say this as I of j omega, suffix j omega, or I can say I of S. For consistency, I'm going to use S instead of j omega. Okay, 2 j omega, this is nothing but 2 j omega, right? So 2s, and this is 1 over j omega c, so this is 1 over j omega, which is s times 1 over 0.5. So can I say this as 2 over s? Okay, this is 2 over s. So in step 1, what we did, we converted the given circuit into frequency domain. Okay, so here is the frequency domain circuit. It's similar to the time domain circuit. All you see is the difference is everything is in S domain. So here we are finding the transfer function. Transfer function is nothing but output over input. Okay, output of everything, please write it in the S domain, I naught of S over I input of S. So what I meant to say, don't leave it I naught over I input. It doesn't make any sense. You have to have S or j omega on the side. That's a suffix. So the transfer function is output current over input current. Now, when you look at here, to find the output current, I can use the current division rule. Or you can find the voltage, and then after that you can find the current passing through that element. But if you know the current division rule, that's easy to find. So I'm going to repeat the current division rule one more time. Say, for example, you have two impedances, Z1 and Z2. They are in parallel. Okay, and you know how much total current is coming in I input. Okay, if you want to find I1, total current I1 equal to I input times opposite impedance. So here I have two impedances. I'm finding I1, which is current passing through Z1. So to find I1, use the opposite impedance in the numerator, which is Z2 over total impedance Z1 plus Z2. Okay, so my I1 over I input, which is nothing but transfer function, because I1 is nothing but the output current, I in is the input current, okay, which gives us the transfer function. So this is what he's asking for. So if you look at here, the given circuit, this is the output current I naught of S, and I can see this branch is parallel with this branch. Okay, so all I need to do is find the transfer function. All I need to do is I naught of S equal to I naught of S equal to I input of S. What is the opposite impedance? Which is 4 plus 2S. 4 plus 2S over, what is the total impedance? The total impedance is 4 plus 2S plus 2 over S. Okay, I'm going to simplify this a little bit. I naught of S over I input of S equal to 4 plus 2S over, now I have 2 over S. I'm going to find the LCM in the denominator, which is S. 4S plus 2s square plus 2. Okay, so I'm going to take the s to the numerator. I will end up with the 2s square plus 4s over 2s square plus 4s plus 2. Okay, this is my transfer function h of s. So h of s is equal to 2s square plus 4s 2s square plus 4s over 2s square plus 4s plus 2. I can simplify a little bit further. If I simplify a little bit further, I can take out 2 as a common. So h of s equal to s square plus 2s over s square plus 2s plus 1. This is my transfer function. Okay, please forgive me, my s look like 5. Okay, 5 I always write down like this and s always like this, but still sometimes you will see my s look like 5. Do not confuse. Please go back and watch what I'm talking about, whether I'm talking about s or I'm talking about 5. Okay, so here is the transfer function for the given electrical circuit. You don't need to convert it back into time domain. That part we're going to learn it in the next chapter. I'm going to start solving another example in this same video. Here is the next example. In this example, he's asking about the transfer function. So the transfer function he's asking about output current over input voltage. So h of s, I'm already writing it down in s domain. You can write it down in time domain too. So in that case, h of t equal to, usually in time domain we always use the small letters. So h of t equal to I naught of t over v in of t. Okay, so this is current over voltage, so it's a admittance. So for anything, what we need to do, the step 1, we need to convert the given circuit into time domain circuits. When I convert this into time domain circuit, this is 2s. My apology, we need to convert this into frequency domain circuit, not time domain. It's already in time domain. So we need to convert this into frequency domain. So it is 2s, and this is 1 over 50 milli times s. So basically, if I take the milli to the numerator, it is 1000 over 50 s. So I'm going to write this as 20 over s. Okay, and everything is in resistance. Now my goal is finding the relation between output current and input voltage, right? So h of s equal to I naught of s over v input of s. Now, so you can use, once it is in s domain or j omega domain or frequency domain or Laplace domain, we can use series parallel combination method. Okay, so that's what I'm going to do. As long as I find this total impedance, say this total impedance equal to z, so v input of s is nothing but I output of s times z, right? So my transfer function equal to I naught of s over v input, my transfer function is equal to 1 over z. So all I need to do is find the impedance in this case, right? So that's what I'm going to do. So I'm going to find the total impedance. Those two are in parallel. So 6 plus 2s is in series. These two are in series. That series combination is parallel with 10 plus 20 over s. Now I'm going to simplify this part first. When I simplify that part, it is 10 times s plus 20 over s. Okay, that's a simplification part. Now this whole thing is parallel with 6 plus 2s. Now the parallel combination, if I take this as z1 and this is z2, what is the parallel combination? z1 times z2 over z1 plus z2. That will give you total z total. So I need to find the z total in this case. So 6 plus 2s times 10s plus 20 over s, and 6 plus 2s plus 10s plus 20 over s. Now I'm going to do the LCM in the denominator so that I can eliminate the s there. So in the denominator I have s, so it's going to be 6s, so I have to multiply 6 with s plus 2s square plus 10s plus 20. Okay, in the numerator here I have 1, but by the way it's a multiplication, so 6 times 10s 60s plus 2 times 10 20s square plus 20 times 6 120 plus 20 times 2 40s divided by s. I have this s, that s is written here. Now I can cancel out s and s. I end up with 2s square plus 16s plus 20. Okay, that is in the denominator. When it comes to the numerator, it is 20s square plus 100s plus 120. So this is the z value. But to find the transfer function, what I need, as I said, I need 1 over z. Okay, all I need to do is reverse this. So h of s equal to 1 over z, which is 2s square plus 16s plus 20 divided by 20s square plus 100s plus 120. You can leave it like that, or you can further simplify h of s equal to s square plus 8s plus 10 over 10s square plus 50s plus 60. All I did, I took out 2 on both in the numerator and denominator, end up with this transfer function. If I simplify further, it's going to be s square plus 8s plus 10, and if I pull out the 10 in the denominator, s square plus 5s plus 6, so s square plus, if I simplify further, it is s square plus 8s plus 10 over 10 times s plus 3 times s plus 2. So here this is a second order system. How do I know second order system? So the denominator, we call this as a pole, and numerator we call it as a zeros. So the order of the denominator tells you how many number of poles are there. So here I have s square, that indicates that I have 2 poles. It's a second order system, will have 2 poles. Fourth order system will have 4 poles, something like that. Okay, I'll stop it here. I'll make another video. In that video I'm going to solve a couple of more examples on finding the transfer function. Thank you.